All right, so the cumulative product function starts with the first element, and as you examine each of the next elements, you will be multiplying to a cumulative product. So this first example, you provide the vector 1 to 5, so those are numbers 1 through 5, and the result is going to be 1. 2 multiplied by 1 is equal to 2. 3 multiplied by 2 is equal to 6. 4 multiplied by 6 equals 24. 5 multiplied by 24 equals 120. Okay? So it's a cumulative product. For each of the numbers in the vector, you multiply it with the previous product and store it in the output. So we will do this without using cumulative product, of course. And we'll do this using for loops. Alright, so when you construct a for loop, you need to identify how many times the for loop is going to execute. So we have a vector, x. We don't know how many elements it has. Our function should work for x that has any number of elements. We'll start from the first element, and we'll keep another variable that keeps the current product. Okay. Another option is to directly use the output vector, and the last element in the output vector is going to contain the product. So I'll do it both ways. Let's do it the first way first. So in the for loop, you need to know where you are in your vector. Okay. So we'll have a loop variable I that will tell us which location we are at in this vector. So the variable I will start from number 1 and go all the way to however many elements you have in the vector. Okay? And inside the for loop, you will make use of I, the variable I, and you will perform an operation only on the element that I refers to. Okay? As I changes, the position you are referring to will change, but the operation that you are performing will remain the same. So let me write the code and then I'll explain again. For I equals 1 to number of elements in X. This gives me a vector that starts from 1 and goes all the way to the number of elements in X. Let me keep a current product starting from 1, and I will say product equals product times xi. So every time I see a new element of x, I multiply it into the product. Alright? And then I will store that product in yi, my output vector. Make sense so far? Okay. So let's examine the inside of this for loop. So conceptually, what you need to do is consider yourself inside the for loop and focus on the task that you need to do when you are inside. So let's consider this problem as a variation of this. So I'm gonna just type in here, but now let's assume a different problem where we are given, let's call this sub-problem. We are given a vector x. We are given the location in x, so the current location, which is in I. We are given a vector y, where we store the output, and a variable product. And in this sub-problem, what we want to do is get the ith element of x, multiply it into the product, and store it in the ith element of y. Okay? So we'll multiply the ith element of x into our product and store it into the ith element of y. Okay, so this sub-problem becomes the inside of your for loop. So it always helps if you can identify the sub-problem inside your for loop and work on that separately, and then put it in your for loop. Okay. All right, let's go back to the original problem. So that's how I wrote down this inside of the for loop. Now let's examine the execution of this function over an example. My product, my cumulative product. Let's give it numbers 3, 5, 7, 20. Okay. What I'm going to do, I'm going to click on this dash line and realize that I have an error here. Click on this dashed line, which will stop the execution at that line, on that line. So after I go back to the command window and hit enter, the execution will stop on that red dotted line, and I can examine the contents of these variables. Let me open the workspace. So variable x has 3, 5, 7, 20. I'm going to step. On Windows, you would hit F10 key. So that will execute this next line, creating a variable product and storing the value 1 in it. Let's hit F10 again. I move into the for loop. I will take on values of this vector one by one. So if I highlight that vector and right click and say evaluate selection, I can see the numbers that I will take on at each iteration of the for loop. So in the first iteration it will be 1, and then in the next iteration it will be 2, and so on. But at the moment it has the value 1. All right, and you can see that from the workspace window. So I has value 1 currently. Then I take the ith element of x. Let's highlight that again and evaluate it. On Windows there's a shortcut key F9 that tells us ith element of x is 3. So the first element is 3. And I multiply that into the product. Product becomes 3. And I store the current product into the ith position of y. Right now, y does not contain anything. Y has not been defined before. When you have a variable not defined before and you try to store something in it, MATLAB will automatically create that vector and store the number 3 in its first position. Okay, so y has been created and it has only a single element, which is 3. So when you are done with the inside of the for loop, the next iteration will begin. It'll go to the top, start over again. Remember, I had to go over each of the values of I one by one. So the next value is 2. Now I contains the value 2. Whenever you see x sub I, you would be interpreting that as x sub 2. So the second element of x is 5. Multiply that into the product. The product now becomes 15. And store the result in the second element of y. And then do the same thing for the third elements of x and y. So I is now 3. You take the third element of x, multiply it into the product, store it in y. And then you do the same thing for the last element of x. I is currently 4. All right. So whenever your function does not work correctly, it helps to debug and run your function step by step, examine the contents of the variables, and making sure that they are what you expect them to be. Okay. All right. So let's simplify this function a little bit. One thing you might have noticed is that I don't really need this additional variable product. The vector y will contain the last element in vector y will contain the product that I need. Okay, so let's initialize y to be 1, a vector with a single element, and that element is 1. And I'll say yi equals yi minus 1 times xi. And I'll start I from 2. Let me draw what's going on here. I have a vector x. I have a variable I, which helps me refer to each of these positions. I started a vector y that only contained a single value of 1. The reason I'm starting with 2 is I've already taken care of the first element of y. Okay? So I know I don't have to refer to this first box again. Actually, that one was a mistake. We have to initialize it to x1. All right. So when I said y equals x1, I took the first element of x and copied it into y. And then I will take on values 2, 3, 4, and so on. And for each of those, I'm going to take the number inside x, multiply it with the previous element in y. So if I refers to the second box in x, I minus 1 will refer to the first box of y. Make sense? All right. So if you think of x and y aligned, at any position in x and y, if I refers to this box right here, you can refer to the previous box in y using I minus 1. Okay. And then what I'm doing, I'm taking that, multiplying with x sub I, and storing it into y sub I. Make sense? Yes? No? Doesn't make sense? Okay. Let's try this again. So let's go through this step by step. I have vector x that contains 3, 5, 7, and 20. In the first step, what I do is I take the number 3 and store it in the variable y. So y contains a single number 3. And then I run a for loop that takes on values 2 all the way to 4. So when I say I equals 2 all the way to number of elements of x, the number of elements of x is currently 4. So that's the same as saying I equals 2 to 4. And that means I would be, I will be taking the values 2, 3, 4 in the for loop. When I'm inside the for loop, in the first iteration, I will be 2. Okay? So what I'm saying is y sub 2 equals y sub 1 times x sub 1. You just take I and replace it with its value. So it takes y sub 1, which is 3, x sub 2, which is 5, multiply the 2, 15, and store it in y sub 2. Now I've calculated the second element of y. I'm done with the for loop iteration. I will take the next value of I, which is 3. When I is 3, what I would be saying is y sub 3 equals y sub 2 multiplied by x sub 3. So I'm taking y sub 2, which is 15, x sub 3, which is 7, multiply the two together and store it in y sub 3. So you get 105. Okay? And then that iteration is done. The next iteration, I equals 4. Replace the value of I, you get y4 equals yi minus 1, which is y3, multiplied by x sub I, which is x4. So I'm taking the third element of x, third element of y, which is 105, fourth element of x, which is 220, multiply the two together and store it in the last element of y, you get 2100. Okay? All right. Any questions? Okay, so let's change this function a little bit more. So when you are working with for loops, sometimes you need to think about how your variables change size. Okay. So as I calculate the next value of y, I was adding a new box to y. Before that moment, y had one less box than I needed. And that causes MATLAB to increase the size of the vector y inside the for loop at each iteration. It's faster to claim enough space for variable y up front before you enter the for loop. That way, inside the for loop, MATLAB doesn't have to resize the vector y, because resizing is time consuming, especially when you are working with very large vectors. All right. So what I'm going to do is say y equals zeros, size of x. I know that y will, at the end, have the same size as x. And I just create a vector y that has the same size as x and store numbers 0 in it. Those 0 numbers will be overridden, so I don't need to worry about them not being the final answer. And I will only store x1 into the first element of y. So this first line of code will create a vector y and store zeros in them. And you will have as many elements as you have elements in x. And then you will still perform the same operation, copy the first number directly, take the second number, multiply it with the first in y, and store the result in the second element y, and move on. Make sense? Okay. So another thing that we need to worry is sort of some of the boundary cases. Usually when you write a function, you would want it to work for a vector of any size, including an empty vector. Right now, if I call this function with an empty vector, let's try it, I will be getting an error. And where do you think the error will happen? At which line? Line number 1, 2, 3, 4, 5, 6. Okay. Line number 3. So you'll get an error in the first place where you are referring to a non-existing element. All right. So x inside the function will be an empty vector. So you can refer to x as in its entirety. You can ask what size it has. That will not cause an error. Okay. So let's highlight, debug through this function, calling with an empty vector. So x will be empty. Let's highlight size of x, evaluate it. So it has a size 0, 0. And I can create a matrix of zeros having a size of 0, 0. So that's also okay. You get an empty vector as a result. So line 3 does not cause an error. You get y to be an empty vector. But on the next line, what you are doing is you are trying to refer to the first element of x, but x does not have first element. It has 0 elements. Okay. So when you try to run the line, MATLAB will tell you that the index of x that you are using exceeds its dimensions. So you don't have enough elements in x to index. All right. Okay. So what do I do to solve that problem? So there's a special case where x is empty, and I want my function. The most logical thing to do is to have y also empty. So when x is empty, the cumulative product would be an empty vector. It makes sense, right? It still satisfies your problem definition. So what you need to do is you need to write an if statement and only do the following, this chunk of code, when x is not empty. So if number of elements of x is not equal to 0, then do those. Now I've safeguarded this chunk of code against this error that you saw. So this error will not be shown again because I'm only performing this indexing. I'm only accessing the first element of x when x is not empty. So let's run that function again, and you get an empty vector as a result. When you want to check whether a variable, a matrix or a vector is not empty, instead of checking its number of elements, you can directly call a function called isEmpty. So that's an alternative way of asking whether x is empty. And I put a not there because you want to do this when x is not empty. Okay? When you want to run a function only when certain conditions are met, you can wrap your entire function or the block of code inside an if statement. But when you have multiple of these if statements, sometimes your code gets too confusing. Instead, it may be more convenient to check whether x is empty and then stop the function from executing after that point. And there's a keyword called return that will help you do that. So this is another version that will do the same job. So I'm checking if x is empty, then get out of the function. So the rest of the function will not be executed when that happens. Question?
What's the return for?
The return gets out of the function at whenever it's executed. Okay. So whenever x is empty, the execution will go inside this if statement, and return says, I'm done with this function, get out, don't execute the rest of the function. And when you have a return statement, you need to make sure that when return happens, the output variables have already been assigned to something. So if you move this y to over here, you'll get an error if you are trying to use the output variable. Because when you are returning, you have not, at the time that you are returning, you have not really assigned anything to the output variables. So the usual flow of the function code would be set some default variables, some default values to your output variables, check special conditions, special cases where you don't want to run your function, and say return when those conditions are met. And if those conditions are not met, then you can safely write your function and index the elements. All right? Another question? If the size is 1, it'll still work, yes. So when the size is 1, let's give an example and run it step by step. Let's say the input is 5. So you create a vector y that has the same size as x and contains values 0. So y is a vector length 1 with 0 elements, sorry, with the value 0. The next if statement checks whether x is empty, which is false. X is not empty, so that if statement is skipped. And then you take the first element of x, store it in the first element of y. That copies 5 into y. And then the for loop starts from 2 all the way to the number of elements in x. So 2 all the way to 1 will give you an empty vector. So you are executing for loop for 0 elements. The loop variable I will not take on any values. Effectively, the for loop does not execute. Okay, so you never go into the for loop when the possible values that I can take is an empty matrix. So F10, the arrow says it's going to return from the function. Any other questions? All right. So let's move on to the next problem. The next problem is an example of using row and column indices. So the most natural way to think about this problem is to use nested for loops. What nested for loops is, it is a for loop inside another for loop. Okay. So instead of a single variable I, now we'll have two variables, R and C. And actually, let's call them I and J to not confuse them with the R and C in this problem. And they will refer to the ith row and jth column you are trying to access. Okay, so I'm going to start with a simpler version of this problem. Let's just print a rectangle. So this function takes R and C. And so the problem does not say returns, it says prints. All right. Usually in your homework problems, we would always ask you to return the result. When it says print, I'm not going to return it. I'm just going to use fprintf to print the result. Okay. All right. So let me first describe the problem, and we'll take a break while you guys try to solve it. So I have what I'm going to do is I'm going to write a for loop where I will use an index that will help me go through numbers 1 all the way to R. Okay? So I will take on values 1 all the way to R. And I semantically will refer to the row that I'm at. So I equals 1, I will think about it as I am in the first row. And then inside that, I will use another variable j that will go from 1 to C. And inside that, I will just print a single dot, or whatever character you are trying to print. Let's print this pound sign, okay? And then let's close the for loops. So what this will do, the variable I will take the value of 1 and then get inside the for loop. So inside the outer for loop, the value of I is currently 1. And then you go into another for loop where the value of j is 1. And you print a pound key, a pound sign. All right? So the inner for loop is done, but then you have to repeat it for the next element of j. And then when j is equal to 2, you print another pound sign. When j is equal to 3, you print another one, all the way to however many columns you have. When you are done printing all the columns, meaning when you are done looping over the values of j, you would like to print a new line character, so you would move on to the next line. Make sense? So after I'm done printing, meaning I'm at this point where all these C pound signs have been printed, I want to print a new line. Print, let's call it the new line character. And then after that, I'm going to go back to the beginning of the I for loop and assign the next value into I. So I will now be 2, and repeat the same thing over. So it will print these pound signs, and then hit the print new sign again, and repeat that outer for loop R many times. Make sense? Okay, so this function that I just described will print out a rectangle. The question is asking you to print a parallelogram. Okay, so what you need to do is you need to print a number of spaces before you print the first pound sign. So in a way, I need to shift the first line, I need to shift the second line. When I'm at the last line, I don't skip any, I don't print any spaces. So the number of spaces that I need to print at the beginning of each line is dependent on what row I am at. Okay? All right, let's look at this this example again. When I'm in the last row, there's no space. When I am 1 before the last row, there's 1 space. 2 before the last row, 2 spaces. 3 before the last row, 3 spaces. Sorry, 4 before the last row, 3 spaces. So the number of spaces, there's a relationship between the number of spaces and the current row that you are at, and the total number of rows that you would like to print. So that expression, if this is R, is going to be R minus I, is going to give you the number of spaces you need to print at each line. So when R is 4 and I is 1, that means you are in the first line. So first line, second line, these are the values of I's. Third line, fourth line. And then 4 minus 1 is 3 spaces, 4 minus 2 is 2 spaces, 1 space, 0 space. Okay? All right. Since I know how many spaces I would like to print, I need another for loop that runs this many times and prints a single space in each iteration. Make sense? So I showed you how to print these stars or the pound signs or any other character you want. C many times, okay? So before you get into that for loop, you need to have another for loop that prints these spaces R minus I many times. All right? So let's take a short break while you guys try to solve this problem. And if you finish it, send me an email. All right, so let's solve this problem. And again, I'm going to first print a rectangle and then add the spacing at the beginning. So I'm going to have a variable I that will take values 1 all the way to R. And inside this for loop, I sort of need to forget what's outside this for loop and only focus on a single row. I'm in the ith row, and that's all I care about. Okay? So inside that ith row, I need to do something for each column. So let's create another for loop that goes from 1 all the way to C. And fprintf, a single star. And that's all I'll do for each column. When I'm done printing stars, then at the end of my row, I need to print a new line character. Okay? So print parallel 5, 4 gives me 5 rows, 4 columns. Make sense? All right, now I need to print spaces. Before I print any stars, I need to print a number of spaces. The number of spaces will be r minus I. So the variable j will go from 1 all the way to r minus I. That's how many times I would like to repeat this for loop. That's how many times I would like to print a single space. Okay? Alright, so all this for loop does is print r minus 1 spaces. When r minus 1 is 0, it would print no spaces because it would not enter the for loop. All this highlighted for loop does is print see many stars. So you print a certain number of spaces and a certain number of stars. And then after that, you print a new line. And then you go to the next line, next row, and repeat the same thing again. Print a certain number of spaces and a certain number of columns. Sorry, a certain number of stars. Let's save this and call print parallel again. Now you see that the spaces are printed, and then the stars are printed, and then the new line is printed at the end of each line. Any questions? Okay. There is a way to simplify this answer, and you can get rid of some of these for loops. There's a function called wrapmat that you guys learned about, right? So you can consider this for loop as printing r minus 1 spaces. Okay, so instead of a for loop, I can also construct a vector that contains r minus 1 spaces. Okay, so I'll take a single space and replicate it r minus 1 times. R minus 1 row, r minus 1 columns. So I'm taking a single element and replicating it r minus 1 times. That will, as a result, give me r minus 1 spaces. Okay, so let's try that in the command wheel. Let's say r is 10. Let's copy this and see what it gives us. You will not see the result because it's going to print a bunch of spaces which are invisible. So let's wrap this with a pound symbol so we can see the extent of the blank spaces. All right. Okay. So since this is a string, I can use fprintf %s to print it. All right. So I constructed a vector that contains r minus 1 spaces, and I used fprintf to print that string. Next, I'm going to do the same thing for stars. Let me copy this. I'm going to replicate a vector that contains a single star with, C many times. So if C is 5, wrapmat S star C many times gives you 5 stars, and then fprintf simply prints that. After I'm done printing the stars, I will again print the new line character. Okay. Print parallel. Oh, what happened? MATLAB mysteriously disappeared. Okay, so I do have one mistake somewhere that I need to solve. Okay, so do you guys see my mistake? So this is the result I'm getting, which is not the result I wanted to see. So the number of spaces is constant, it doesn't change, right? So how many spaces I'm printing? R minus 1. How many spaces do I need to print on each row? I minus 1, right? So let's change that R to I. And repeat that. You get that. Sorry. Wrong again. It's going to be R minus I. Okay? Make sense? All right. Good. You can solve this problem in a different way considering the parallelogram as a matrix. So you would create a matrix of a matrix of blanks, and then you would index the elements where you need a star and store a star in them. Okay, that's you can actually do it without a for loop, but it's more involved. So let's not go into that. And let me change this back to the nested for loop, since that was the intention for this exercise. For j equals 1 to r minus I, f printf a single space. And equals 1 to c, print a star. Let's test it again. We get the result, so we can move on to the next problem. Any questions about the parallelogram? No. Okay, so in this problem, what we're going to do is find the positive numbers that satisfy this equation. All right. There are multiple ways of doing this. The easiest way to think about is to write a for loop, to write nested for loops that will try each of the values for x, y, and z, and see if they satisfy this equation. Okay. So what you will do is you will have a for loop for x that goes from 1 to 20. And for each of the values of x, you will have a for loop that tries the values of y 1 to 20. And for each of those, you will have a variable z that goes from 1 to 20. And inside that, you will check whether x squared plus y squared equals to z squared. And if so, if that condition is met, then you need to store those three numbers, x, y, and z, in your output matrix. Let's call it R18. Okay. So these three for loops try all combinations of x, y, and z. And when the equation is satisfied, you store the result. You store the values of x, y, z satisfying that equation in your output matrix. Okay? And you are also additionally printing these statements, so you would have a printf statement here that will print this expression. All right, so what this will do is it will try, let's say, it will print 3, 4, 5, but it will also print 4, 3, 5. So to prevent that from happening, you can change your if condition to additionally check that x is smaller than y. So you just say x squared plus y squared equals z squared, and x is smaller than y. But a smarter way of doing it would be to look at your for loop and make sure that the values that the variable y takes never go below x. So instead of y going from 1 to 20, you can have y go from x to 20. Mathematically, you can start from x plus 1, but let's not worry about that. So if y goes from x to 20, then inside the y for loop, you are guaranteed that y will never be smaller than x because you are starting the iterations from the value of x. Now you are avoiding the cases where x is equal to 4, y equals 20. So those will not be printed. Make sense? All right. Another thing you need to sort of handle is creation of this RET. If you don't initialize it, in fact, you probably wouldn't initialize it because it's difficult to predict beforehand how many rows you're going to need, right? So in each, whenever this condition is satisfied, you need to add a new row to RET. So if RET at any point has a certain number of rows, you need a way to refer to the 1 plus that. So if RET has 10 rows at any point and you need to add a new row, you need to say RET END plus 1, comma 1 colon 3. So you are referring to 1 past however many rows RET has and the first 3 columns, and then storing the values of x, y, z in them. Okay. So you will store these into these boxes. All right. So before you start this for loop, you need to initialize RET. One way of doing it is saying RET equals an empty vector, and then the first time you find the numbers that satisfy the equation, so those are going to be 3, 4, 5. You will run this line, and it'll store 3, 4, 5 in the first row of RET because END plus 1 is going to be 1. So when the RET is empty, END will be 0. You would be referring to the first row, first 3 columns. Since it does not exist yet, MATLAB will automatically expand, resize the RET matrix to accommodate the new values you are storing. Okay. So in one of the previous examples, when an element did not exist, you got an error, right? But you would get an error if you try to extract values from that position. If it is storing that you want to do, then MATLAB does not give an error and it resizes the matrix to accommodate the new values. So there's a distinction between reading values and writing into a location. Writing into a non-existent location does not give you an error. MATLAB will automatically resize, but reading from a non-existent location will give you an error because MATLAB does not really know what to return to you. Any questions? Okay, do you guys want to give it a shot? No? Who says yes? Okay, everybody's looking back. All right. So let's solve this problem. Edit. Okay, so I'll have a for loop that goes through 1 to a and tries each of those for the value of x. Y equals x to a, z equals y to a. You can start from 1 to a, but it will never be satisfied for values that are less than y. So let's just do that. And then you'll write an if condition that says if x squared plus y squared equals z squared. And we need to print this thing. Let's say fprintf %d times %d plus %d times %d equals %d times %d. Now I need to have as many arguments as I have %d's. So x, y, y, z, z. So that's just to print those equations on the screen. And then the next part is to return the x, y, z in a matrix, n plus 1, 1 all the way to 3 equals x, y, z. And let's initialize RET to be an empty vector. Okay. So let's step through this function. Pythagorean 20. RET is initially empty. Let's look at the workspace so you guys can see the values that these variables take. Okay, so x is 1, y is 1, z is 1. Is it satisfied? No. So you skip the if statement. Try the next value, z. Z equals 2? No. So let's keep going. It'll take us a while to find a condition that's met. So now x is 1, y is 2, z goes through numbers 1 to 20. Now x is 1, y is 3, and I'm getting tired of hitting the F10 key, so what I'm going to do is I'm going to put a breakpoint inside that if condition and run until MATLAB hits that hits that debug point. All right. So I'm going to on Windows there's a shortcut key called F5. On Macs it would be a different key. So when I hit F5, it'll keep looping, and when it gets to that line that I want to break at, it'll stop there. Okay. Question?
Why is it n plus 1?
N plus 1. I'll explain it in a minute. Okay, so fprintf prints 3 times 3 plus 4 times 4 equals 5 times 5. I didn't put a new line. That's why the output is not very pretty. So let's put a new line there. And then RET END plus 1. Before I got here, RET was empty. Right? RET was a matrix that had 0 rows and 0 columns. So RET was let's say it's an empty thing like that. Okay? If you say REND, END would be replaced with the number of elements, which is 0. If you say REND comma something, then this END would again be replaced with the number of rows in R, which is 0. Okay? But you really want to store into the first row. That's why I say END plus 1. However many rows it had at that point, you want to add a new row to it. That's why you need to go one beyond however many rows it had before that. And you are adding 3 elements in each row. Okay. So RET has 3, 4, 5 now. And let's hit F5 again. It gets there. 5, 12, 13 is printed. And then 5, 12, 13 are stored into the second row of RET. And if you look at RET, you have 3, 4, 5, 5, 12, 13. Make sense? Okay. So let's change this function a little bit. Instead of saying RET is empty, it's usually better to say RET equals 0 rows and 3 columns. So even when no numbers satisfy that condition, you still sort of know that RET should have 3 columns, right? So it's sort of a semantic issue. 0 rows, 3 columns, but what that allows you is to replace this 1 all the way to 3 with a single column. Okay? So at this point, RET, the first time that you hit that point, RET will have 0 rows, 3 columns. The E and D keyword will be replaced with 0, and then you have +1, so that refers to the first row, and the colon says all columns, so all 3 columns. So if without this, if you don't declare how many columns the matrix should have, you cannot use this colon sign, colon operator. You would have to say 1 all the way to 3. Okay? All right. There are a few mathematical based things that we can do here. For instance, you don't really need to loop over the values of z. You can calculate a value for z from x and check if it is an integer. So let's do that. So z equals square root of x squared plus y squared. Okay? Now I've removed one of the for loops. But what I do need to check is whether z is an integer. How would you check whether z is an integer? So if z is any number, let's say it could be 3.5 or it could be 5 or 6. You need an expression that will tell you whether it's a whole integer. How could you do that? There might be a function, but yes? Yeah. Z equals 6.5. Mod of z comma 1 gives you 0.5. So that's one way. Another way is to take the floor of z and check whether it's equal to z. Okay? Or whether the floor is equal to ceiling. Or whether rounding is equal to the same number. So z equals 6. It's true. That means it's an integer. Okay? But let's use a suggested solution. Mod z with 1 equals 0. It's an integer, and we do the prints. F. We need to provide an input 20, and you get the printouts and also the output vector, the output matrix. All right. So there's one error here. The question was asking you to have x, y, z smaller than a. Since I removed the innermost for loop, which was having me go from z values 1 to 20, and replace that with this mathematical equation, now I need to additionally check whether z is less than 20. So I would say z and z is less than 20. Or z is less than or equal to a, let's say. Okay. So now you remove that last entry and making sure that z is less than or equal to a. All right. Any questions? Okay. So there's a function in MATLAB that helps you create a mesh of values. So in this problem, you have 2 for loops that try all combinations of x and all combinations of y. So in a way, you are looking at a grid of x and y values. So let's consider this coordinate system. So you would be looking at each of these points, right? x1, y equals 1 all the way to 20. x2, y equals all the way to 20, and so on. MATLAB has a function that will generate these combinations for you, so you don't have to write a for loop. Actually, you still have to write a for loop, but it's a single for loop instead of multiple for loops. And that function is meshgrid. Okay, let's look at the documentation for meshgrid. We provide two vectors, and it will give us two output vectors. Meshgrid 1, 2, 3 with 1, 2, 3. So that will give us all combinations of these two vectors. It will give us 1, 1, 1, 2, 1, 3, 2, 2, 2, 1, 2, 3. Okay, and you need to collect both x and y. So x and y are matrices now. As far as you are concerned, you really want them as a vector. So let's convert x to a vector, all right, and y to a vector. And let's put these two vectors together and create a single matrix. So now you have all the combinations in a single matrix. Effectively, what you have is a single matrix that contains all the values that x and y would have in these for loops, except now y would go from 1 to a. All right. So let's use it. Let's use meshgrid function to solve this problem. So you'll create a meshgrid. You are creating a grid of values, and let's create the single matrix xy that is x linearized and y linearized. So xy will contain all the combinations of values that xy will take. Now I can have a single for loop that will go through the number of rows I have in xy. Okay, so size of xy comma 1 will go through these values for me. So 1, 1 will be the first row that I'm looking at. 1, 2 will be the second row. Okay. Next, I will do the same thing here. Square root of, instead of small x, I will have xy sub I comma 1. That's the first number. xy I comma 2. That's the second number. And the rest are the same. But since I now have all values of y that go from 1 to 20, I need to ensure that xy I comma 1 is less than xy I comma 2. Okay? So instead of writing two for loops that iterate over values of x and iterate over the values of y, I've created a single matrix that contains all combinations of values that I need to consider. And then I look at rows of that matrix. The first element is the value of x. The second element is the value of y in each row. So instead of small x that I had, now I would have xy I sub 1, I through first column. Instead of the small y that I had, now I have xy I comma 2. And the rest are the same. Okay, so let's test this. Pythagorean 20. Empty matrix. So something went wrong somewhere. When something goes wrong, what you need to do is debug. All right, I already see where I went wrong. Instead of 1 to 3, I need to say 1 all the way to a. 1 all the way to a. Okay, let's test it again. Undefined variable x. So I need to replace all occurrences of x with xy sub I1, and all the y's I have with 2. Z's are the same, and x, y, I throw, and then colon will get me the first 2 columns. Okay, so I no longer have to say 1 and 2. Let's run this again, and I get the answer. All right. Now there's an important step from here, going from here to vectorizing the entire code. What vectorizing means is you would be changing your function in a way that you will no longer use for loops, but you will use matrix operations. Okay, so for the sake of illustrating that, I will change this problem, and well, we can still print it, but let's not worry about printing at the moment. Okay. All right. So let me print this XY matrix again. Where was it? Mesh grid, and then X. That. So when you look at this matrix, what you can do is you can create a third column that will be the first column squared plus the second column squared and their square root. Okay? So I'll take the first column squared, the second column squared, take their square root, and store it in here. Okay? So effectively, what I'm doing is I'm performing this line, but I will be doing it for all the numbers at the same time. So XY is that matrix with 2 columns. Now I'm going to say XY third column equals square root of XY all rows first column square plus XY all rows second column squared. Okay? Now you get that. All right. After I have that, I need to check my additional constraints, which where the first column should be smaller than the second column, and the third column should be an integer. So let's take that, put it in here. And for that, I'm going to use a logical vector. Logical vector I will be true whenever the equations and the constraints are satisfied, and it will be false whenever it's not satisfied. So what are my constraints? The main constraint is that mod of the third column should be equal to 0. Okay? So if I take the third column and take the mod of that, that will give me a vector, 0.4, 0.23, 0.16, and where I do have integers, it'll be 0. By checking whether it is 0, all of the ones that have fractions will become 0, and this one will become true. Okay? So that's one of the constraints. Another condition that satisfy is that the first column should be smaller than the second column, less than second column. So what that will do is I'm extracting the first column, so that's the first variable, the first value, it's a vector, and the second column, and performing less than, which we'll look at them individually. So 1 less than 1, no. Your resulting vector is going to be false. 1 less than 2, yes. 1 less than 3, yes. 2 less than 1, no. 2 less than 2, no, and so on. Okay. So you created a first logical vector, which looked at whether the third column is an integer, and another logical vector that looked at whether the first column is less than the second column. And when you add the two together, you'll get ones only where both logical vectors have true in them. All right? Okay. So now I have a logical vector I that has false wherever the matrix xy does not contain the numbers I'm interested in, and it will have a 1 wherever there's a set of numbers that satisfy those conditions. So I need to index matrix xy, use logical vector I to select rows from it. So xy and I are different sized matrices. I is a column vector, xy is a matrix with 3 columns. But you can take I as a logical vector and use it as a mask for rows of xy. You would only be referring to the rows of xy for which I has true in it. So xy equals xy I and that. And that matrix xy is the matrix that I'm going to return. Let's run this function again. Let's look at the errors we get. It says that the operands and or must be converted to logical scalar values. So the double and sign and the double or sign only works when you have a single number on both sides. If you are trying to perform logical and or logical or on vectors or matrices, you need to use a single and or a single or. So when I run, I get the answer. Okay. If you want, you can add the printing again. It's just a trivial for loop going over rows of xy and doing fprintf times %d plus times %d plus equals times %d. And I believe fprintf is smart enough to handle a vector with multiple numbers in it. So you don't really need to have a separate number for each %. If you provide a vector, it'll do the corresponding for you. No, it didn't. Oh, so there was one error. I said I equals size of xy to x, the number of rows in xy. I really needed to say 1 through the number of rows. Let's do this again. So what did I get? All right, I'll do this the long way. Since I need to do rep math, well, let me write the solution and then you guys can worry about what it means. Okay. All right, I used rep math, and what I did was I had, let's say, the first row was 3, 4, 5. I replicated it into 2 rows, and then I kept the number of columns the same. So I got this as a result. And fprintf, when you provided a vector with or a matrix with multiple numbers, it'll go through each one and match them with %ds. Okay. So that's how it got printed. Any questions? Okay. So why would I use this instead of doing for loops? For loops are usually costly, and you always need to consider alternative ways of performing the same operation using matrix operations, which are usually faster. So for this example problem, you may not see the effect, but for larger operations, there's usually a significant speed up when you use matrix operations compared to for loops. Any questions? All right, so that's going to be the end of this lecture, and we have 7 minutes